Hi there, it's Mr. Blistein. I hope this screencast finds you well. As you again may have assumed, this screencast deals with the area formulas of a parallelogram, rhombus, and trapezoid. So we're going to both take care of the formulas and also refresh your memory / details about those respective shapes. And then we'll walk through 6 practice problems, 3 of which will be relatively straightforward, and 3 that'll be a little bit more challenging. But either way, I will walk you through all 6. So first and foremost, a parallelogram is a quadrilateral, a 4-sided shape with 2 pairs of parallel sides. So here are 2 examples of what a parallelogram could look like. And you also need to be aware of the fact that the sides that are parallel are also congruent. So by definition, top and bottom are parallel, right and left are parallel. Same thing for this one. In addition, though, the top and the bottom are congruent and the right and left are congruent. Again, these marks themselves just mean parallel. You have to also know that the sides are congruent. Excuse me. As far as the area formula for a parallelogram, that is base times height. So look at these 3 diagrams. In all these cases where the height and the base meet, they're creating a right angle. And sometimes that occurs within the shape, as you can see here and here. Sometimes that occurs outside the shape. Again, in this case, this is the height, and the base is just this side right here. But we have to extend it to at least see where the height and the base would have met to create that right angle. Again, in this case, the base is just this. We just add the black tick mark to show where the height would have met it if it had been that long. As far as a rhombus is a type of parallelogram with 4 congruent sides. So all the properties a parallelogram does, except all 4 sides are congruent. So I'm not marking the things that are parallel because it's included in the definition, but all these sides are the same as is the case here. As far as the area formula for a rhombus, that is 1/2 d1 times d2, and those mean the diagonals. So the diagonals are on the segments within this rhombus, right? The red one being diagonal 1, the blue one being diagonal 2. And 2 things are happening with those diagonals. They are both cutting each other in half, and where they meet, they are creating right angles. So if you can see the 1 tick mark, and 1 tick mark tells you this diagonal, I mean this piece of the diagonal and this piece of the diagonal are exactly the same. They're congruent. And as far as the blue diagonal, this part of the blue diagonal and this part of the blue diagonal are congruent. Likewise, there are 4 right angles all created right here where they meet. And our last shape is a trapezoid. That is also a 4-sided shape of quadrilateral with only 1 pair of parallel sides, and those sides are called the bases. So here's the more traditional view of a trapezoid, one you might be used to. Again, top and bottom are parallel. They may or may not be congruent, probably not. But top and bottom are parallel. And here again, the right and the left were the parallel sides in this case, so those would be the bases for that particular trapezoid. Again, those marks mean parallel, not congruent. As far as the area formula for a trapezoid, that is 1/2 times the sum of base 1 and base 2 times the height. So again, the bases were the parallel sides. So in this case, it was the top and the bottom. In this case, it was the right and the left. And again, the height's going to go from one base to the other, but it must create a right angle. So in this case, I drew it in right here. Again, it's within the shape, and it's creating a right angle. For this particular trapezoid, the height was actually one of the sides that already existed. It was this side right here that connected the bases and created a right angle. So those are our formulas. We're now going to try again 6 problems. The first 3 will be relatively direct, and the last 3 will be a little bit more challenging. Either way, I am going to walk you through all 6. So let's start with the first one. It says sketch rhombus EASY, or easy, and then find the area of easy given that ES equals 20 inches and AY equals 14 inches. So even if you think you can visualize it, it would be smart to at least draw, sketch, and label, and then we'll see if we can actually calculate it out. So as far as a sketch, there's the rhombus that I chose to draw. Again, you can do any order you want as long as E connects to A connects to S connects to Y, and Y back to E. It doesn't really matter where you start, but you do have to make sure that is happening. E must connect to A must connect to S must connect to Y, and Y must connect back to E. So there's the diagram. Now, as far as labeling ES, ES is not one of the sides, and AY is not one of the sides. Those are what we call the diagonals, which actually is a good thing for us because if memory serves, our formula deals with diagonals. So I go ahead and threw in my diagonals there. I wrote down the formula, and I'm going to plug in the proper numbers. So ES, the red diagonal, was 20 inches long, and D2, the blue diagonal, AY, was 14 inches long. And as far as calculating this, this is 1/2 times 20 times 14. It is not 1/2 of both of them. So you can type it all in at once if you'd like, or you can do half of 20 and then times 14. For what it's worth, you could also do half of 14 times 20 if you really want to, but just make sure you're doing the times half once, not twice. Either or, if you type that in, you should get 140 square inches. Let's try another. This one's asking you to find the area of the parallelogram below. So it's telling you what kind of shape it is. So now it's just a matter of finding the proper formula and using the values given to do that. So for a parallelogram, the area formula was base times height. And in looking in this particular picture, the base is given to you as being 23 inches, and the height was, 23 centimeters, and the height is 9 centimeters. So we just go ahead and throw them in and we multiply. And that should be it. Just as in the past, plane units are used for how long, how tall, how wide. Square units is used to communicate how much space or area. Third problem, we're being asked to find the area of trapezoid ABCD that you see below there. All right, so we got to get the right formula out. So go ahead and do that, and then in turn, put in your proper values and see if you can calculate it. All right, let's see what you got. So there's the formula. Plugging in the values and working it out. Remember, the bases were the parallel sides. They may or may not be the top or the bottom. They are the sides that are parallel. And it wasn't noted as parallel in the diagram, but you were told it's a trapezoid. And based on the diagram, yes, you can go ahead and infer that A, B, and DC were the parallel sides, and they were indeed the bases. 8.8 in this particular situation was useless. It was just kind of a distractor. All right, those were our first three. Now let's try three that are slightly more challenging. Number 4, you're being asked to find the area of the parallelogram. So just as before, let's make sure we get the proper formula out. And if memory serves, to get the area of a parallelogram, the formula is base times height. Well, in this diagram, I see the base of 38, but the height just does not seem to be there for us. That said, if I look at the diagram where I put the H and I see the height there and the right angles, I'm hoping you see a little right triangle. Well, if you have a right triangle and you know 2 sides out of the 3, isn't there some theorem that you know to help you find that third side? Hope so. Hope you're thinking about Pythagorean theorem. Let's see what we can do. So H and 10 were the legs, 26 was the hypotenuse, so that would have been your step to trying to find height. Again, remember, squared means times itself, not doubling. So 10 squared is 100, 26 squared is 676. You then subtract 100 from both sides, leaving you with 576. And the square root of 576, cursive a calculator and or your brain if you have that memorized, which I certainly do not. The square root of 576 was indeed a nice, neat 24. Now that is not the answer, right? You just found the height, but you were being asked to find the area of the parallelogram. So your job now is to take your height and throw it into your equation. And hope you would calculate it all the way out and get 912 square feet or feet squared. Let's try another one. You're being asked for problem number 5 to sketch rhombus math or MATH with MA equal 25 yards and AH equal 14 yards. Find the area of math. Again, saying sketch, so it would be in your best interest to do so. Even if you think you can visualize it, maybe you take the heat of the problem and you attempt to sketch it. So again, do whatever you want. Just make sure M connects to A connects to T connects to H, and H connects back to M. Where you actually start putting the M is really up to you. As long as M to A to T to H, and H back to M is what allows you to create the rhombus. So I sketched my rhombus, and I put my 25 there as far as for the side, that's MA. But AH is not a side. AH is what we call a diagonal. So I'm going to draw that in momentarily, but please don't assume it's one of the sides. Mark it, draw it, label it, and then read. You should notice that AH is not one of the sides. So I threw in the diagonal there. And then being that it was a rhombus, I wrote down the formula for area of a rhombus, which was 1/2 diagonal 1 times diagonal 2. Okay, well, we have diagonal 1. It was given to you. Diagonal 2 is nowhere to be seen. So maybe we have to draw it in. That diagonal would be connecting M and T. So let's go ahead and draw that diagonal in. All right, now I did a little more than that. I split that 14 into 7 and 7, because if you recall from your notes, the diagonals of a rhombus are perpendicular bisectors of one another, meaning they cut each other in half, and they create right angles. So the right angle symbol was noted, and it was 14 all the way across. That means it has to be 7 and 7 each. That said, the blue diagonal was cut in half, but the blue diagonal also cuts the red diagonal in half. So I don't know what they are, but I know they are exactly the same. And I'm going to note that with those two X's. Still don't know what they are. I know they're the same. I do see a right triangle there. And yet again, we seem to know 2 out of the 3 sides. Wonder what we can do here. Hopefully you're thinking about Pythagorean theorem. Let's see what we can do with the X, the 7, and 25, and apply it to Pythagorean theorem. Right? X and 7 were the legs, so leg squared plus leg squared, or X squared plus 7 squared, equals the hypotenuse squared, or 25 squared. We work this out. 7 squared is 49, 25 squared is 625. Excuse me. You'd subtract 49 from both sides, leaving you with x squared equals 576, and I feel like we just saw that number. We did. The square root of 576 is 24. Now, please note, 24 is not the diagonal. 24 was just the x, which was half the diagonal. So the entire diagonal from M to T is going to have to be double that, or 2 of those, meaning diagonal 2 is actually 48 units long, or in this case, 48 yards long. All right, well, this is the formula we're going to use to find the area. We didn't have the second diagonal, but we just found it. Let's go ahead and throw it in there and see what we get. Well, 1/2 times 14 times 48. Again, remember, it's not half of both numbers. So the way I think of it as half of 14, which is 7, times 48. You could, if you want to be doing half of 48, which is 24, times 14, but it's not half of both values. Also, for what it's worth, when we did the work and we found just half the diagonal, some of you might be thinking, well, can I just do then 24 times the entire diagonal times 14? And that would absolutely work. You are allowed to do that if that's something you thought about. All right, and our last problem, problem number 6. You're being told the area of a trapezoid is 110 square inches, or inches squared. The bases are 13 inches and 7 inches, and you need to find the height. All right, so let's start like we've been starting every problem thus far. Let's write the proper formula down. So for a trapezoid, it's area equals 1/2 of the sum of base 1 and base 2 times the height. Let's go ahead and put in the values that we have. So we had the area and we had the 2 bases, so I'll put those in there. Let's see if we can clean up a little bit, which is to say, by order of operations, right, you have to do inside the parentheses first if you can. In this case, we certainly can. We can indeed add 13 plus 7. All right, we don't know what h is, but we can certainly take half of 20. So half times 20 is 10. That means 10 times something, or 10 times h gets you 110. So hopefully dividing by 10 on both sides leaves you with a height of 11. So your answer would be the height is 11 inches. I hope that wasn't too bad for you. And as always, feel free to go back and watch it again a little more slowly if you'd like. Likewise, feel free to reach out for any help you need. We'd be happy to help you. Take care.